In this section, we'll be talking about converting between fractions and decimals. The most important thing to remember for converting from fractions to decimals is fractions are division. So all you need to do is to not overthink this and divide the top number, the numerator, by the denominator. In this case, you're also being asked to round to a certain place. So once you've done that division, make sure that the place that you end your number is where you're being asked to round. I'm going to read the specific instructions because you need to get used to always reading the details. Often on tests, I suspect it's because of stress and anxiety, things like that, people rush through. They look at a problem and they figure, yep, I know how to do that, and they do it. If there are any details in the directions, like where to round, students will miss that, or reminders about units. So as you're practicing, as you're watching videos, make sure that you always pause and read the directions. So the first one, it's describing what I just said in terms of what the video covers. But notice this last sentence. It says round decimal answers to the 10th place unless otherwise specified. Now looking at one, just the problems that we have right here, they all indicate where to round. So that basically negates the instruction for these because you are told specifically where to round. But future problems, you may not be told where to round, and so that would then apply the 10th place rounding. So be really careful about that. Don't rush. So for 1A, it says write the following as decimals rounded to the indicated place. So A, we have 3/7. So remember that this is the same as 3 divided by 7. We don't use that division sign anymore, but I want to remind you how the fraction lays out in the format that we have more experience with. So it's always the top number, the numerator, being divided by the denominator. So I'm going to do 3 divided by 7. Woo, it's a lots of decimal places. So I get 0, and then let's see, it says to round to the 1,000th place. So that means 3 places to the right of the decimal. So I have to put at least 4 so that I know what's happening to my rounding. So as you're writing out the fractions, basically in summary, make sure that at least there's 1 place further than what you're rounding to. Otherwise, you don't know what happens to that last place value. In this case, I need to pay attention to the 8 because that is the number in the 1,000th place. I look 1 to the right. It's a 5. 5 or greater means that I'm going up. So I have, 429,000th is my rounded final answer. Since I rounded, it's no longer an exact answer. It's only approximate, whereas fractions are exact. A lot of times, as you start working more between fractions and decimals, there will be times where it's really important that you don't use decimals because we are looking for an exact answer. It should be indicated in directions, whether we're dealing in decimals or fractions, or there's that general rule, if you don't have decimals in problems to start, you should not be working in decimals and your answers should not be in decimals. Occasionally, again, those directions may state that you need to round your answer, which says decimals, but if you don't see that, you need to stay in the integers and fractions. So next one, we have -2/3. And we're rounding to the 100th place, so 2 places to the right of the decimal, which means when I write my answer down from my calculator, I need to have at least 3 places. I know because this is a negative divided by a positive that my answer will be negative. So I divide 2 divided by 3. I get 0. And then I need at least 3 places to the right. There's my 100th place. Here's my 1000th. I'm just to make sure that you're introduced to this. This is a decimal that repeats constantly. It's a repeating decimal. If you have that and you're not being asked to round, you can put the line that I just did above it, and that shows that it goes on forever. So you'll see that sometimes. So I want to make sure that you are comfortable with what that means. Now I'm ready to round. 2 places to the right is my 100th. I look 1 more place to the right. It's 5 or greater, so my 6 has to go up. So I get 0 and 67 hundredths. And that is my final answer. Go ahead and pause the video and try C, and then turn it back on and see how we do this one. So we have worked with fractions like this, where the numerator is bigger than the denominator. Think for a second, what kind of fraction is that? What word goes with a fraction with the numerator greater than the denominator? Hopefully you thought improper fraction. I focus on vocabulary because as I'm talking, and as you move forward in math, things just become a normal part of the language. And if you're not comfortable with it, it's very, very difficult to keep up with lectures and if you're working with groups. So make sure that you're paying close attention to the vocabulary that's being used. Now, the fact that it's improper doesn't change any of our process, but I want you to start connecting what your brain is seeing, what your eyes are seeing, to what your brain is thinking, so that if you do have an instruction that says, for example, convert this to an improper fraction, you'll know exactly what you're being asked to do. All right, we're dividing. So numerator divided by the denominator. Just for practice, I'll go ahead and show it again. I know I didn't in B, but this is what we're actually being asked to do, right? So I'm going to do 11 divided by 9. That gives me another number that goes on forever. I'm going to draw my line. I need to round to the 10th place. I look 1 to the right. Well, it's less than 5, so that means that my place is unchanged. So my final answer is 1 2/10. So division, right? These are ones that my students often overthink. My guess is fractions often feel overwhelming. They're everybody's favorites. They certainly are mine. Hopefully you heard the sarcasm in that. So remembering that, one, as you practice, you'll get more and more confident, right? And 2, there are a lot of different things that we do with fractions. And while some may seem much more difficult, and that's totally fine, wherever you are is where you are, other ones are not. They are much, I hate the word easier, but in comparison, right? So yes, you just divide the numerator by the denominator, follow the same rules for division, right? Dividing negative and positive gives you a negative. Dividing 2 negatives give you a positive, and so forth. All right, so don't overthink. Okay, so for 2, we're now going the other direction. So the naming convention on these can really help in figuring out how to write these. When you're dealing with numbers that also include whole numbers, there are 2 different ways that you can do this. I will go ahead and show you both ways the first 2 times, so for A and B, and then D, I'll show you my favorite way, and then you can choose. As always, in some, you may decide to do one way and others you do another. You just start figuring that out the more of these that you do. So the instruction here is write each decimal as a fully reduced fraction. So don't forget that reduction part. anytime we've been dealing with fractions, we've talked about making sure things are fully reduced. And in a previous video, I showed a couple of different strategies, for example, using prime factors to ensure that your fractions are fully reduced. I also talked about using the number in the fraction that you're more comfortable with in terms of the factors, and using that list of factors to test to see if the other number, numerator or denominator, is fully reduced. I encourage you to go back and review those strategies if that's something that you don't feel very confident in, because again, it takes practice. Okay, so we need to remember when we look to the places to the right of the decimal, what the name of that place is. The reason that's important is because it tells you what your denominator is. So for the first one, I have 23 and 14 hundredths. Well, 100 is your denominator. Now, when you write a denominator of 100, you are rewriting the decimal. So the decimal is no longer. So we get, in this case, 23, but now that decimal moves over twice, and we put that over 100. The reason that works is because, again, it's division. So if I divide 2,314 by 100, the nice thing about dividing by multiples of 10 is the number of zeros that you have is the number of times your decimal moves to the left. I've got 2 zeros here, so I divide to the left twice, right? So that's why putting your denominator under there cancels that decimal. It's the same value, it's equivalent, you're just writing it in a different format. All right, to remove any confusion, I am going to erase that because it's the fraction that we need. Once we have the fraction, we can go ahead and reduce it like any other fraction. So in this case, I recognize that both of these are even numbers. The numerator ends in a 4, so that's even. The bottom, the denominator, ends in a 0, so that's also even. So I know at least the number 2 goes into both of those. So that's where I'm going to start. So 2,314 divided by 2 is 1,157 over 100 divided by 2 is 50. Well, in looking at this, I may not be sure whether that's fully reduced or not. So this is a great opportunity to practice the strategies for figuring out whether it is fully reduced. Now, I look at 50 and I am far more comfortable with all of the factors of 50. So I'm going to make a list of those. 50 is a factor. Well, I already know that 50 does not go into 1,157. But if you're not sure, just go ahead and divide it out. You will get a decimal. Then I have 2 times 25. So I'm basically doing my prime factor. So does 25 go into 1,157? It doesn't. How about 2? Nope, because 1,157 is not even. Then 25 goes down to 5 times 5. Well, 1,157 doesn't end in 0 or 5, so I know that 5 doesn't go into it. So that's my confirmation that this format, 1,157 divided by 50, is fully reduced. Now, in your instructions, it could tell you to write your answers as a mixed number. It doesn't, so I'm not going to convert that, but do make sure you always double check. It goes back to that, make sure you read the directions, the main directions for the assignment, right, the test, whatever, and then the details of each problem type. So this second way is to look at this as two parts, okay? So notice I've got the 23 underlined here. A mixed number includes a whole number and a fraction. So what I can do is I can write that whole number, so 23, and then I just rewrite the decimal portion as a fraction. So in this case, it's 14 hundredths, right? Because it's just two places to the right of the decimal. Now I need to just pay attention to this portion of the number to fully reduce. In this case, both numerator and denominator are even. So I'm going to divide top and bottom by 2. I get 23 and 7/50ths. And that is my final answer. Now, if you were to convert this number, you would get the same thing. I prefer the second way, but if it's something where you don't, that is absolutely fine. I know when I'm teaching and writing problems, I don't tell people within this process which one to do. You can just go ahead and do whatever works best for you. So let's move to B. I think you're ready to go ahead and pause this, right? And try B and then turn it back on, or try all three of them. That is just such an important part of determining what you're understanding and what you still need to review. All right. So for B, this is another one that has a whole number. So I'll do both methods first. And then again for D, I'll just do that second method because I do prefer it. All right, so I look at this number and I see that I have one place to the right of the decimal. Well, that means to undo the decimal, I need to put that value without the decimal over 10, right? Because again, dividing by 10 moves that decimal over 1, which gives me the whole number, and then it's divided by 10. Now I have a number that ends in 5 and a number that ends in 0, so I automatically know that 5 comes out of both of those. So I get 7 over 2, and that is my final answer as an improper fraction. So let's do the second method, where we keep that whole number, the 3. Then we take the number to the right of that decimal and we put it in the numerator. And then because it's just one place, that denominator is still 10. I don't do anything with reducing. Imagine, so this fraction is saying that I have 3 whole pies, and then I have part of a 4th pie. Well, those 3 pies, you can't do anything to them, right? You can't reduce them. So the whole number always stays the same, and then you can just reduce the fraction. I actually recommend this as another way of checking whether your fractions are fully reduced if you have an improper fraction. So we have the using prime factors. We have using the factors of one of the numbers that you're more familiar with. And now for improper fractions, you can convert to mixed numbers and then just reduce the fractional part. And usually they're far smaller numbers that you're working with, which is what can make it a lot easier to do. Again, there's that word that I don't love, but it is easier than just sticking with the original bigger numbers. All right, so I see that 5 goes into both of these. So I get 3 1/2. And sure enough, if I were to convert the improper fraction to a mixed number, I would have the same answer. All right, if you haven't done so already, go ahead and pause the video, and then I'll go ahead and do 2C for you. So this one, I don't have a whole number. So there's only one way to do this. Once again, it's how many places to the right of the decimal are you? Well, you're at the 100th place. That means that my denominator needs to be 100. So my decimal moves and I get 25 over 100. Let's see, actually, I was going to write my equal sign, but I want to go ahead and show the division, right? Because I do have a common factor. 25 goes into both of these. Now, this is the greatest common factor, the GCF. So the biggest number that goes into both of those. That means that I'm getting my reduction done in one step. If, however, you started with 5, that's okay. You'll just end up doing 2 rounds of reduction. The only time it's not okay is if it specifically says in the instruction to reduce using greatest common factors, or it may say reduce using prime factors, right? So again, that's one of those instructions. You need to make sure that you're understanding the format of the answer that's wanted, as well as the process that you're being asked to do. All right, so my final answer is 1/4. Okay, D, the numbers are getting bigger, but that doesn't change the process. So I said for this one, I'll just go ahead and go straight to this method, right, where I just pull the whole number out and deal with the number to the right of the decimal as the fraction. So here I have 132. This is one place to the right of the decimal, so I know my denominator has to be 10. Then I put the 4 in the numerator. I can reduce that fraction by 2 because they're both even numbers. Now I rewrite the whole number, and then I write what my new fraction is. And that is my final answer. Couple of methods, choose which one you prefer. At the same time, always practice all of the methods, because at times you may be asked to use one over the other and you want to make sure that you know how to do it. Now, I do recommend to students, as you're learning new strategies, to practice. I usually say to start with the process you're less comfortable with when you're doing homework, and then you can do the one you're more familiar with to check whether you have that new process down. As you're learning math, a big part of learning math is learning new tools, right? And so if you're not taking the time to use those tools, then it can be, very difficult to get those new tools learned. An example of that is starting with addition and subtraction, right? You then use multiplication and division because your numbers are getting bigger. The context of where you're using the problems are different, more complex. So if you're still stuck with addition and subtraction, those problems would be so cumbersome, and the likelihood of mistakes is extremely overwhelming. And there are times where those foundational skills don't work. So you have to be learning these new strategies, and the only way to do that is to practice. Now for 3, we are putting these numbers in order. Anytime you're being asked to put something in order, whether it's decimals or fractions, you need to get them into the same format, especially if you can't look at a decimal and know what the fraction is, or the other way around. Now, I think I'm going to go ahead and let's convert the fractions to decimals. I find that to be a less complex process because we are just dividing the numerator by the denominator. But if you want to convert the fractions to decimals, you can totally do that. In fact, if whichever of those methods you're less comfortable with, those are the ones that I would use to convert these. All right, so I need to convert this fraction and this fraction to decimals. I know that the negative 5/3 is going to be negative, so I'm just putting that negative ahead of the actual calculation. And so I have 1, and then it's 6,666. It goes on forever. Well, here, the most places I have to the right is 2. So I need to make each of these fractions decimals that go to the 100th, which also means because I need to round, some of them I may not actually need to round, but I always need to check. I have to write out at least to the thousandth, right? Remember that it is one place beyond where you're rounding to. So here, that's my hundredth. I look over here, right? It's 5 or greater. So that means this number becomes 7. So my replacement for the fraction is -1 67 hundredths. I'm going to do the same thing for the 3/4. If you're not sure what 3/4 is as a fraction, as a decimal, go ahead and just divide. But 3/4 is 0.75 or 75 hundredths. So now I'm ready to order everything. Okay, so negative values will always be the smallest. So let's look at the negative values I have. I have -1 4/10, and I have -1 67 hundredths. Negative numbers are smaller the further they are from 0. So you always, if you look at a negative number and it looks bigger, so in this case, if these were positive, right, 1 67 hundredths would be bigger than -1 4/10. However, we're in the negative, we're to the left of 0. So -1 67 hundredths is smaller, right, than -1 4/10. So that means my list, I'll write my list over here just so it's separate from the work. My list starts with that number. I have one other negative, so I'm going to use that number next. And now I need to compare my positive numbers. For my sanity, I'm going to just circle what's left. And so in looking at those, the closer you are to 0 on the positive side, the smaller the number. So in this case, 75 hundredths is closer to 0. So that's my next one. So I'm done with that. Do my comma. Now 2 26 hundredths is closer to 0 than 2 3/10. They're very close, right? But anytime what's to the right of that decimal is smaller and your whole number is the same, that one with the values to the right being smaller is the smaller number. All right, so I'm done with that one, and then I have 2 3/10 remaining. So there you go. The key thing on that, again, is to make sure that the format of all of the numbers in your list are the same. Eventually, you may be comfortable with enough fractions that, for example, 3/4 I know is 75 hundredths, so I don't actually need to run that calculation, and you'll probably start running into that, where you become more comfortable with the decimal equivalent of a fraction and vice versa.